Okay, so another problem. This problem is as follows. I have here a rectangular box. It has width 3, length 5, and a height of 4. And what I'm being asked to calculate in this problem is this distance, this long diagonal from here, from this point to this point. That is from here to here. Put it in green so that we can see it. That is from the, if I call this the front of the box, from the front left top corner to the back bottom right corner along here. And maybe I will call this distance here, keep it in green, I'll call my distance x. So I'm being asked to calculate that distance x. The only information I have is that it is a rectangular box and it has these dimensions, 3, 4, and 5. So how would I go about calculating that distance x? Well, the way I'm going to approach this is, again, by using the Pythagorean theorem. Whenever I'm using the Pythagorean theorem, I'm always looking for right triangles. That's really my strategy, so that if I can find right triangles, I know that I can apply the Pythagorean theorem to those right triangles. That might be helpful. Straight away, I notice that if I join this front bottom left corner to this back bottom right corner, that is right from here to here, and I'll put it in solid right there. That's this distance from here to here. Then what I have is a right triangle right here, right there. There's a right triangle looking in this direction. I have a right triangle for this distance here, which let's call this distance here, let's just call it y, and x. It's my long side. So I have a right triangle here. Unfortunately, because I don't know two of the sides, it's not very helpful to use the Pythagorean theorem there yet. The question I might ask myself is, can I possibly calculate this distance here, y? Would there be a way to calculate that? And I think that I see that there is a way I might do that. If I were to take a bird's eye view of this box and look straight down, that is, if I were to look sort of this way, right, such that I'm looking down in this direction, straight down, I can see that I have along the base of my box here another right triangle. That is this right triangle right here. There is a right triangle, 3, 5, and this distance y. And because I have a right triangle and I know two of the sides, the Pythagorean theorem allows me to calculate this other side, this side y. And so that is going to be my approach. My approach is going to be to solve for this distance here, y, using this bottom right triangle right here. And then once I know that distance y, I'm going to apply it to this triangle right here with my long side of x. That's going to give me that distance x. That's going to be my approach. Okay, so to begin, in this bottom triangle right here, that is, again, looking straight down from above, looking straight down this way, I have a right triangle with the two legs of the triangle, 3, 5, on the long side y. So that is that I have that 3 squared plus 5 squared is equal to y squared. 3 squared plus 5 squared is equal to y squared. That's what the Pythagorean theorem tells me. I can now solve this. That's 9 plus 25 is equal to y squared. 9 plus 25, that's 34. So therefore 34 is equal to y squared, and therefore y is equal to the square root of 34. So this value here is the square root of 34. Hopefully you can see that. Square root of 34. Okay, now because I know this distance, just calculated it, and I was given this distance of 4, I can now use these two and the Pythagorean theorem again to solve for x. I have a right triangle here. You can draw it if you'd like. Draw it up here. This is my length x. This is a right triangle. This is my length x. This is my height 4. That's here. And this here is this length along here. That is, we just worked out as the square root of 34. So I can use the Pythagorean theorem one more time. Pythagorean theorem here would tell me that 4 squared plus, that's the square root of 34 squared is equal to, alongside that's x squared. 4 squared, that's 16, plus the square root of 34 squared. Well, the square root of 34 squared is obviously just going to be 34. Square root of 34 squared, that's 34. And that's equal to x squared. 16 plus 34, that's 50. And so I have that 50 is equal to x squared. X, therefore, follows that x is the square root of 50. might simplify this for myself. The square root of 50. Is there any factors of 50 that are themselves squares? Yeah, 25 is a factor of 50. So this is the square root of 2 times 25. 2 times 25 is 50. I can take out my 25 from underneath the square root sign, and so I get that x is equal to, when 25 comes out, it's 5. So that is 5 root 2. And that's my answer. I always like to check to see approximately that is. I use my calculator. Square root of 50 is, it's approximately 7.1. And the only reason I do this is to check to see if my answer makes sense. Well, I have a side length of 3, height of 4, length of 5 here. So 7.1, that makes sense. Makes sense to me. I don't think I've made any mistakes. This answer is correct. And that's how you would find this long diagonal in a box like this. It's simply being able to see that there are right triangles that you can make, that you can form, and you can apply the Pythagorean theorem once you have done that. You may have to apply it more than once, like we did in this question. But that's how you go about it. Okay.